Most developers pick a vector database by asking how much data they have. Wrong question. First time I did this on AWS, I went straight for the fastest option. My app had 4 users, 2 of them were me testing, and the other 2 were also me testing. AWS gives you 4 ways to run vector search. In this video, you will learn about all 4, plus the rule for when to choose each, so you optimize for your use case. Quick refresher on what vector search is. So normal search matches letters. Someone types, cancel my subscription. Your documents say, terminating your plan, and you get nothing back, even though they mean the same thing. Same meaning, but 0 shared exact literal words, literally. Vector search fixes that. A model turns your text into a list of numbers, and similar meanings produce similar numbers. Those 2 phrases land right next to each other because they have similar meanings. Nobody can tell you what any individual number means, including the people who trained it. We've all agreed not to bring it up. A vector database stores those numbers and finds the closest ones. All 4 AWS options for vector search covered in this video do that. 2 questions you can ask to help you figure out which option works best for you. First question, will anyone actually be waiting on the search? Sometimes nobody is. A batch job, for example, runs overnight, so speed doesn't matter. Or a chatbot feels the same way. A user is waiting, but they're waiting on the model to write its answer, which takes a few seconds. The search happens somewhere inside that wait, so nobody really notices that extra 50 milliseconds or 300 milliseconds. But sometimes, as you're typing, the search results are the screen. A shopper types in a search bar and stares at the spinner until products show up. Nothing slower is happening to hide behind. Now, speed is everything, and even a fraction of a second feels slow. Second question, besides finding the closest meaning, does the search have any other rules to follow? Sometimes it doesn't. Closest meaning is the whole job, and you're done. But sometimes there's more. Maybe it also has to match an exact part number, letter for letter. Or maybe it can only show a customer their own data, never anyone else's. Maybe there's some nuances. So closest meaning might not be enough on its own. The search has to respect those other rules and those other nuances as well. So being able to answer those 2 questions will help you have a clear idea of the choice. So let's cover some scenarios. Scenario 1, a chatbot over your internal docs. 10 years of wikis nobody has opened since the person who wrote them left the company. 200 employees ask it twice a day. Nobody's counting milliseconds because it's a chatbot. You're waiting for a response. That's Amazon S3 vectors. It's cheap because you're not renting a server. You pay for what you store and what you search. Pick it when nobody will notice the wait and you store far more information than you're searching for. A small app still counts as long as something slower is happening after the search. Skip it when search is the thing that people are staring at. For example, a type ahead search needs single-digit milliseconds latency, and this isn't that. Also, skip it when the searching never stops. Each index serves hundreds of queries a second before it throttles you, and you're paying per search the whole time. Scenario 2, a store's search bar. Thousands of shoppers watching a spinner. Half of them search warm jacket for hiking, and the other pastes in the exact product model number. Vector search nails the first because of meaning, but on the second, it hands back 3 products that feel spiritually similar. A product model number isn't a concept, it's characters. You need keyword and vector search in one query. So in this case, pick OpenSearch when someone is waiting, and exact words may have to match too. Skip it when your archive is enormous and almost nobody searches it. You'd pay more per gigabyte than you need to. Scenario 3, a SaaS app already on Postgres, for example, where results must never cross between customer accounts. Your database already knows which customer owns which data. A separate vector database doesn't. So you're copying data and enforcing that rule twice. Pick pgvector when the data already lives in Postgres and the search has to obey rules your database enforces. Skip it when your vector index outgrows the memory on your instance, or when you need keyword matching too. Scenario 4, recommendations on every page view rendering before the page paints. That's Amazon MemoryDB. Everything held in memory, the fastest option here. Pick it when this runs on every request, and OpenSearch still isn't fast enough. Otherwise, you're paying for memory prices to serve that docs chatbot from scenario 1. Here's the good news. You're not locked into whatever you pick today. So start with S3 vectors, the cheapest option, while you find out whether anyone actually uses your app at all. If your app takes off and you need more speed, you don't need to rebuild anything. One button in the console copies your vectors index straight into OpenSearch. And if your app flops and nobody shows up, you've spent about $1 finding that out, which is roughly what my 4-user chatbot should have cost. So, 2 questions every time you build one of these. Will anybody be waiting on the search? And does the search have any other rules to follow? Answer those and you'll pick the right one. If you want to try it out with an app you are currently building, I recommend setting up your AI coding assistant with the AWS Agent Toolkit so that it sets up whatever option you choose correctly for you, and you can be assured that your agent is following best practices around that particular service. Link to how to set up AWS Agent Toolkit is in the comment section below. And that's it. Have fun. Let me know if you have any other questions related to the different options for vector search on AWS. Peace.